Thank you, thank you. Hi, I'm Nicholas Prusinski, again down at Caltech. Can everybody hear me? No? You need me to shout? Oh, the microphone? Does this work? Yes? Okay, sorry. Okay, as advertised, I'm going to be talking about KCRM, the Keck Cosmic Reionization Mapper, which is the red channel of KCWI, the Keck Cosmic Web Imager, leading to all sorts of fun new acronyms like the Keck Cosmic Web Imager Reionization Mapper Imager. In any case, I'm here speaking on behalf of the entire KCRM team, the multitudes of people throughout many years who have gone into making this instrument become a reality. So I'd like to extend a special shout out to Matt Matuszewski, Don Neal, Rosalie McGurk, who's in the audience, and of course the PI, Chris Martin. For those of you who are unfamiliar, I'd like a quick refresher. KCWI is a seeing limited optical integral field unit, and as a result you have several different image slicers which adjust your field of view between about a half an arc minute by a third of an arc minute all the way down to about 8 to 20 arc seconds. You have a slew of gratings on both the blue and the red channel of varying resolutions to suit your science needs, and as a result you have different band passes and resolutions, sort of ranging between the 1,000 to 20,000 range on the blue, 1 to 10,000 or maybe 15,000 on the red. This, as you can see, is an image of KCWI sitting on the Naismith deck with a little bit of cabling. It's having a bad hair day, and it has googly eyes. As an outline, I'm going to start with talking about my post-DRP stacking code, which allows you to stack the individual cubes, and that was something I worked on as a visiting scholar this past summer out in Hawaii, and I'm going to use that to motivate some of the early science results we've been seeing, and I'll talk about a few of those examples. There are several stacking codes on the market as of right now. CWI Tools is tailor-made to Cosmic Web Imagers, so it deals with the three-dimensional structure of these cubes. CCD-Proc and Reproject are two algorithms that are AstroPi affiliated. Reproject does a cubic interpolation onto a common grid. CCD-Proc is more or less just a stacking code with some fun bells and whistles for CCD rejection, or cosmic ray rejection, that sort of thing, sigma clipping. The Pipet team is working on their own complementary DRP for KCWI, and there's an associated stacking code there. And the montage package is designed by the folks up at IPAC, and that actually drizzles your images onto a common grid. And I'm aware that some of you in the audience probably have your own custom codes that you use for this sort of thing. And all is well and good if you're dealing with images like you see on the right there, where you're more or less in the same position, and you're taking multiple exposures, and all is fine. But the minute you start going to images like this, where you're in multiple position angles, you're dithering between exposures as you should because you want different pixels to be getting the light, and then you're in a bit of a pickle. So for our code we're going to be publishing it uses montage. It takes as an input a set of, or more or less a list of your constituent exposures and some final stacking parameters. What do you want your final scale to be? What do you want the size of your final cube to look like? And from that, it goes and does some fine alignment, it does WCS corrections, and it outputs more or less what you get as an input. So you input these data cubes, and you output a stacked intensity, a variance cube, a mask, and an exposure time cube. So you can actually tell which pixels went into which cubes went into which pixels in the final step. So the alignment procedure looks as follows. Take a label image with a line on the target, and as you proceed, you resample each of those images on the grid, aligning onto one target. So we're working on this. We're working on doing some cosmic ray rejection with the red side during stacking, and also incorporating both sky-subtracted and non-sky-subtracted cubes as different extensions. So you can see where the sky model works, where it doesn't, and where we need improvement. I have far too many of these slides, but we will continue. This code can also be used to mosaic, so you can have disjoint cubes. You do not have to have them all spatially overlapping. Just supply a size of your image that you want it to be, and you can move everything around as required. We're also exploring the possibility of using multiple grading angles. So the red side, if you could choose the low resolution grading, you only have about 350 nanometers of a bandpass, but the astute observer will note that the red side is capable of going between 5,000 and 1.1 microns, so you have about 5,500 angstroms to work with. You can then take several different grading angles or different central wavelengths, take data in both of those configurations, sum them together. They don't have to be spatially coincident, and you can concatenate the spectra together. So on the left, you see the central wavelength of 7,000 in blue. On the red, you have the red RL 8,000 and the concatenated spectrum together. Windows update. I'm now going to proceed to talk about some of the commissioning data. Let me just preface this briefly by saying thank you to all of the observers who submitted targets for the KCRM commissioning run. I think we're probably approaching order 100 targets by now that all the observers have submitted. So thank you again for doing this. Naturally, with only 10 commissioning nights, we've only been able to observe a handful of those objects, but we appreciate this. This has been an excellent testing ground for the DRP and some of the post-DRP we've been working on. So without further ado, I'd like to present Vivian Yu's and Justin Cater's target. This is VV340A. And I'm just going to show a few examples, a few white light images here, but Justin and Vivian are the people to talk to if you have further details about this. But this is an excellent object that we were able to look at. So we got in two configurations. We got about 2 hours in the large slicer, and you can see the observing pattern in the front. You start in the center, and you sort of dither around into 4 regions. And on the bottom, you see H-alpha images and nitrogen-2 white light images using the large slicer. So definitely lots of interesting work there. Because of the nature of KCWI, you can get complementary blue side or simultaneous blue side data. So I'm putting up the H-beta image and the oxygen 3 on the right. You can see that in the O3 image, I have a laser pointer, there's some sort of extended shock front right there, or at least it appears to be. So we were looking at this with a large slicer, and we thought maybe we can do better, maybe we can observe this shock front with higher resolution. And indeed, if you look at the spectrum, we went from the large slicer to the small slicer, and this is just a visual representation of the increase in resolution that you get by changing your observing mode and at the cost of your spatial field of view. So we changed slicers on the same object, zoomed in a little bit. That gives you a white light image you see in the bottom corner. And you take images with the large slicer that look like that. And with the small slicer, you end up with images that look like this. Same sort of thing, H-beta, O3 on the blue side, H-alpha, and nitrogen-2 on the right. So all of a sudden, you can see this spatial structure, all sorts of fun structure, lots of wiggles in the H-alpha map. There appears to be some sort of dust lane in the center, even more apparent with nitrogen-2. We only, as a point of note, this is only about a half an hour with the small slicer and the high resolution gratings. So it's quite incredible what you can get in such a short exposure. You can look at this spectrally, so white light image on the left, and if you can see, you have a blue spectrum here that corresponds to this blue square of pixels that I'm integrating over. And as you move across the galaxy, you can see there's quite an interesting velocity field. You have emission from all of your famous spectral features, and there's different variations in intensity, variations in velocity. You can see you have double-peaked regions on the order of a couple hundred kilometers per second, suggesting, again, quite an interesting velocity field, something quite exciting. Here's sort of a zoom in with nitrogen-2 of what that looks like. So you have changes in peak shape, you have changes in the peak profiles, and you have peak separations that change just by moving a small distance horizontally across that image. A better way to sum this up is with a velocity map. This is highly preliminary, but it's just sort of a proof of concept of what you can do now with both sides together, and you can take your famous emission lines and you can make sort of large-scale velocity maps with these. And again, you have some sort of bulk rotation or some sort of bulk motion, at least in the radial direction. So there's a lot more to be done here, but it's certainly very exciting at the beginning. And it wouldn't be complete without saying that now that you have both channels, you can make a spatial BPT diagram. So this is taking just about 3,000 points from that image and plotting them on a BPT diagram. So there's obviously a lot more work to be done, preliminary, but this is something that's now you're able to do at quite high resolution and with relatively short exposures for bright objects. I'm going to move on and talk about a couple of the other objects we were looking at just to showcase what the instrument is capable of. And to start out with, this is one of Zara and Lynn's targets, a grad student down at Caltech. This is a quasar at about a redshift 0.6. We have extended magnesium-2, extended oxygen-3. The Fireball team that Zarin is a part of is hoping to launch in a couple weeks and get extended spectra. Is hoping to get extended spectra with Lyman alpha, or see extended Lyman alpha halo with us. So more to come on this object. FLS6 is one of the first look Spitzer images. This was put forth by Lin Yan, and we're trying to see here, this is a star-forming galaxy, face on early type galaxy, and we're trying to see if this is, if there are AGN components. You can see the morphologies of the H beta image and the oxygen-3 image are slightly different, and we're gonna see in concert with James Webb data if we can say if we can determine the relative importance and contributions from each of these components. This is what the spectra look like for that object. Again, it's 0.6, so you're going to see similar features in the red, but there might be some star-forming regions there and some outflowing magnesium too. Again, we're working on this, and more to come there. Sri Kulkarni suggested we look at the Black Widow pulsar, and indeed, with the large slicer, we're able to see an extended bow shock as this pulsar moves through the interstellar medium. So we see H alpha, we see H beta. We do not see oxygen 2 as he was suggesting, but this is definitely something very promising and quite a very nice image to look at. So it goes without saying that the DRP is still in the works. There's a number of issues that remain a thorn in our sides. Cosmic rays, sky subtraction being at the top of the list. We have solutions in place, and we're working on those. But just for those of you who have submitted targets and we've observed your targets, please stay tuned. There's a whole list of reasons why the data are not in your inbox at the current moment, but we're working to get you the highest quality data products we can with the DRP as it is. So this is an iterative process, as you might imagine. And I'm going to end with some points that I've already mentioned. The DRP under active development. Again, the data we have and the targets you've suggested have been an excellent testing ground for the capabilities of this instrument. It's a very exciting time to be using KCWI, and the possibilities are it's quite a wide scope of science that you can address. I'd also like to plug a few people's talks that'll be going into more detail here. Justin Cater's going to be giving one on Friday talking about AGN. He's again the person to ask about VV40, that object I talked about at the beginning. Yugong is going to be talking about a KCRM observation that he was doing with HERO 3, and Rosalie McGurk is going to be presenting a poster on a broad KCRM overview. So that'll be happening in poster session A. And with that, I'm happy to take questions.